about rational exponents. And guys, these are just exponents with fractions. So the first part of our lesson today is honestly, guys, it is just going to be basically rewriting. If you have an exponent that is a fraction, you can actually rewrite it as a radical. Okay? And so this right here, so I would love everyone to close their Chromebooks because right now we're taking notes. Thank you so much. So here we go. So guys, there's two ways that this can be written, and this is on your formula chart as well. So guys, what we have is if we have a to the m over n, where your exponent is an actual fraction, you can rewrite that as a radical, all right, with a radical. But what happens is the a is your base, and guys, that still stays your base. The numerator of your fraction becomes the exponent inside the little radical here. And then the denominator of your fraction becomes the root. All right, y'all? So the root of our radical. So we've mostly just been doing square roots, things that have a root of 2. But guys, you can actually take a root of 3, a root of 4, and different things like that. So when there's nothing there, it's considered a square root, which is just a root of 2. I think that's one of the only times your invisible number is a 2 in math. Most of the time, your invisible number is a 1. But with your square root, your invisible number is a 2. So you guys, you can see it like this. It can also be written with parentheses, all right, where you have m over n. And then, guys, if that's the case, then sometimes your exponent can be on the outside of your radical as well. So it can be written both ways. And guys, basically what I'm going to do is I'm going to kind of separate this out so that we can write our lovely little rules here. So guys, your base, this little a right here is your base. And so when we are going from one to the other, your base stays your base. All right? And then if we are going to go from let's use green here. The numerator of your exponent up here, which is my m. So guys, my numerator becomes the exponent on this guy right here. Wow, that is a very thick marker that I'm not going to use. All right, guys, so your numerator becomes your exponent. And then, guys, your denominator, the n down here, your denominator becomes your root. All right, the number on the outside. So honestly, guys, a big part of this is just like the puzzle factor of like what goes where. Is this my base? Is this my numerator? Is this my denominator? Is this my exponent? Is this my root? We just have to figure out which one goes from which. So guys, this is just a matter of going back and forth from one to the other. So if we look at this with just numbers right here, guys, if we had 8 to the 1/3, we could rewrite that fractional exponent or rational exponent. We could rewrite that as with a radical. And guys, we look at this and we say, okay, 8 is my base, so 8 is still my base. And then we would say, okay, 1 is my numerator, so 1 is my exponent. 3 is my denominator, so 3 is my root. So if we do those guys here, then, and here's the deal, guys, you don't actually have to, when it has a exponent of 1, you don't really need to write that. So this would then become root 3 of 8. There we go. And guys, that actually does have an answer, root 3 of 8. And so if you guys go here and you can type into your calculator this little guy right here, your root 3 of 8, and it actually gives you a nice little 2, okay? So sometimes you get a nice pretty answer. In this case you do, because 2 times 2 times 2 gives you 8, so 2 cubed is 8, and the root of 8, the third root of 8 is 2. Yes, sir?
You want to show us how to get there again on the calculator?
How we get there from there? So if you go to the little math button right here, you can pull up all sorts of little different things right here. So there's the cube root. If you want to put in any random number, you choose that one right there, and then you can put in like 5 or something like that. Does that make sense? So you can kind of do it that way. But really what we are doing is we're not really calculating it. What I want you guys to focus on is rewriting it properly, okay? So for this one right here, so that's number 1. And then, guys, for number 2, if we rewrite this, we would write it, let's see here, we have 27 to the 2/5. So then, guys, if I wanted to rewrite that, I would write my little square root symbol. And then my base is 27. My exponent is going to be the 2. And then my root is going to be the 5. So all we are doing, guys, is just rewriting the fractional exponents as radicals. Does that make sense, guys? We're just going back and forth between the two. I'm not actually asking you guys to find the value of that or evaluate it, okay? I just want us to ask us to go back and forth. Now, where you see this a lot is you actually also see this with expressions, okay? So in your homework today, you're going to see some of these guys with expressions. So if we had something like 2xy squared to the 3/4 power, well, guys, we could write this 2 different ways, okay? We could write it with, so to the 3/4 power, we would write our little radical. And, guys, this entire thing right here, 2xy squared, that is my base. So that entire thing right here, 2xy squared, is inside the radical. That is your base right here, okay? All of it together because it's inside that parentheses. My numerator becomes my exponent here, and then my denominator becomes my root. So, guys, you could see it written just like this. And, guys, that's all I'm asking you to do is just to rewrite it. Okay, I'm not asking you to bring it power to power or anything like that. I just want to know that you can rewrite it from one to the other. And, guys, we can also, you also could see it. Depends on how they want to write it. You could also have 2xy squared like this. And your parentheses could be outside of your radical. So sometimes your parentheses is inside your radical. Sometimes that parentheses is outside of your radical. It's kind of annoying because both of those are 100% correct. And to be totally honest, there's not really one that is over the other. You could do it either way. Okay, you could do either or. So both of those are 100% correct. I personally, when I write them, I prefer to put my parentheses inside my radical because I just like keep it all nice and contained. But you can also have your parentheses outside of your radical. Cool? All right. Now I'm going to show you guys one more here. So if we have 4 and we say, let's say something like 3a to the 4th to the 1/5. Well, guys, if we're doing it to the 1/5, well, we would rewrite it with our little radical here. So I'm going to put my parentheses, 3a to the 4th right there, because that is my base. My numerator is the 1, and my root is the 5. All right, guys? But if something is raised to the first power, do we really need to have anything to the first power? So no, how you would really write this is, guys, you could just say 3a to the 4th, and that's the root 5 right there, the 5th root of 3a to the 4th. So you don't really need the 1, and so in that case, if you don't have an exponent, you can kind of drop your parentheses there. Okay, so this is just us going back and forth between the rational exponents to the radical. Rational exponents to the radical. Are you guys okay with that? Yes, ma'am.
Do we have to take away the 1? Like, would it count it wrong if we...
It would not count it wrong if you kept the 1 in there. Okay? So I do not think so. I do not think it would count it wrong if it kept it in there. So, but I want you guys to understand that you don't necessarily need it there. Okay? So, guys, that is going from the exponent to the radical form. Now, we are going to rewrite. We are going to go the opposite direction. We are now going to rewrite the radical as a rational exponent. All right, guys? So now we are going to rewrite our radical as a rational exponent. So for this one right here, number 5, we are going to have the cube root of x to the 9th. So guys, if we have cube root of x to the 9th, then how would we rewrite this as a rational exponent? Any ideas for me? Go for it, Sarah. Go for it, Sarah.
X to the 9 over 3.
Yep. So we have x to the 9 over 3. That's perfect. Guys, can we simplify that any further, 9 over 3?
Yeah.
So what could that actually also be?
3.
Just x to the 3rd, right? 9/3 simplifies to 3. All right, guys? So that's just x to the 3rd. So x to the 9 over 3 is just x to the 3rd. But guys, Sarah was exactly right. She kept her base. She made the exponent the numerator, and she made the root the denominator. So that is exactly correct. All right? Let's do, we're going to do 2 more here. So guys, if I have one like this, where I have, let's see here, I'm going to do 3x to the 8th, and we're taking the 5th root there. So guys, if the entire thing under your radical is in a parentheses right here, then this entire little guy right here, 3x, that whole thing is your base. All right, guys? So this right here becomes 3x. Okay, that is my new base. And then what is going to be the top of my exponent? What's going to be the numerator of my exponent?
8.
The 8. Perfect. So that becomes 8. And the denominator of my exponent is 5. That's all I'm asking you guys to do. However, guys, if I write it like this, 3x to the 8/5, what it thinks that's doing is that's only putting the 8/5 on the x. So you've got to make sure you put it in parentheses so that the entire thing is your base. So guys, this is going to be important. If your base is an expression, so if it has like a 3x, or if it has, basically anything more than one letter or one number, if your base is an expression, you need to use parentheses. All right, guys? Use those parentheses. All right, guys? So make sure if your base is an expression that you use parentheses. Cool? All right, let's take a look. We will do 2 more like this, and then you guys, we will be done with this guy. So here we go. If we see something like this, where we see the square root of, let's say, y to the 3rd power. So guys, how would we write this one? What is my base in this case, y'all? Just the y. I don't really need a parentheses because it's not an expression. It's not more than one variable, or more than a variable and a number. So we have that little y right there. All right, guys. Then what is the top of my exponent going to be? 3. And then this one is fun. What's the bottom of my exponent going to be? Okay, so usually if there's an invisible number, it's 1. But y'all, this is a square root, and so your invisible number in this case is a 2. I believe this is the only one of the only times in algebra that your invisible number is a 2. Okay, guys? And probably back in the day when there was when they were first using radicals and things like that, they they use that little 2 right there. But guys, the square root is the most common radical. So because it got used so often, they probably just ended up dropping the 2. Does that make sense, guys? So if there is no number written outside of the radical, it is 2. All right, guys? That is one of the only times that your invisible number is a 2 instead of a 1. Basically, every other time your invisible number is going to be a 1. Yes, ma'am?
So there can't be can there be like a 1 there?
No. Because it's just a number. So the square root, the root symbol basically tells you how many times are you multiplying something by itself to get that answer. And so it sounds a little bit weird. So if you're multiplying it 1 time, then it's just the number. So if it's a 1 root, it's just the number. So it's not. So no, we don't ever use a 1 root. Okay. So there we go. So then, guys, last little example right here. This is a good example of when your invisible number is a 1. So if I was going to take the 4th root of 2x, oops, sorry. There's no parentheses right here. Ignore the parentheses. If it was 2x y cubed, guys, in this case, what is the cube referring to? Just the y. So, y'all, this right here, this entire thing is your base with your cube. Your cube is included. Okay, so this entire thing is your base. All right, because that cube only affects your y. It doesn't affect all these other guys. So, guys, in this case, we have 2xy cubed. That entire thing is your base. But what is my exponent? What is everything being raised to, y'all? Just a 1. All right, guys, so that entire expression is being raised to a 1. So that would be 1 over 4. All right, guys, so this is as simple as just kind of figuring out the puzzle pieces and going back and forth. The trickiest part is just making sure that you keep your base together inside your parentheses, okay? So, so guys, the ones on your homework should be pretty good with that, but guys, that's just as simple as kind of going back and forth between the two of those, all right? Things that we have going on. So guys, for our application problems right here, it says this expression m cubed raised to the 4th power m squared is equivalent to my. So what is the value of y? So guys, we have a few different things going on right here, right? We have m cubed raised to the 4th power, and then that is going to be times m squared. So guys, what rule are we doing right here first? Yeah, power to power. So we are going to multiply that. So this guy becomes m to the 12th. Are you guys okay with that? So that's m to the 12th. And then, guys, we still have our m squared right here. Okay? What's going on? So, guys, this is our power to power rule because we're raising it to the power. So the first thing we had to do was multiply our exponents. Then, guys, now m to the 12th times m squared. What are we doing with our exponents right here? Yes, ma'am?
Adding?
Yep, we're adding our exponents. So now, guys, we are using the product rule. So m squared or m12 times m squared is going to be m to the 14th. Do you guys feel good about that? Because now we're adding our exponents. So 12 plus 2 gives us 14. And guys, it said is equal to my. So guys, what is it asking for? What is this question actually asking for? What is the exponent? What's the value of our y? So guys, what is y equal to? 14. The exponent, the final exponent here is our 14. So guys, basically it wants you to simplify them and then find out what is the final exponent right there. Well, it's going to be m to the 14th. Yes, sir?
You would write it like that instead of like the m14 equals m1?
Yeah, so because it says what's the value of y, and so probably if this was like a multiple choice problem, it would have like 12, 2, 14. It would just have numbers as your answers, if that makes sense. So basically, guys, it's just kind of thinking like we can say what's the value of our exponent. So guys, number 2 is very similar. This right here just gives us our product rule, right? If cx times cy is equal to cx plus y, and C9 and CF equals C4, what is the value of F? So guys, basically it wants to know what does the value of that exponent need to be in order for that to be equal to C4. So guys, if we have C9 and CF is equal to C4, guys, what's the value of that F right there? Ah, very good. Because, guys, really what we are saying is we are saying that 9 plus F is equal to 4, right? Because that's what you would normally do. You would add those two exponents together in order to get the final exponent. And so then Barron did some lovely backwards math there, and your F would be equal to negative 5. So in order for this 9 plus what gives us 4, well, it's plus a negative 5. So guys, sometimes when you add those guys together, you could have a negative exponent. Do y'all feel good about that? Yes, no, maybe so? All right, so I want you guys to try to do, let's do number 3. Number 3 is very similar to number 1. I want you guys to go through that guy on your own right here. And then tell me what the value of m. Basically, guys, what's your value of your exponent going to be? First, we got to do that product to product rule. And when we do that, what is the final, when we do x20 times x18, guys, what's our final exponent going to be? 38. So all I'm asking you guys to do is find out the value of that exponent. So you guys are exactly correct. In this case, my m is equal to 38. All right, guys, what is the value of our m right there? So first we did the power to power rule, and then we did the product to product rule. All right? All right, number 4 is interesting because now we have some decimals. But guys, this box has a length of 10x squared y4, a width of 4.3xy to the negative 2, and a height of 3.5 x cubed y squared. What is the volume of the box? So guys, if our volume is length times width times height, what do I need to do? Just multiply them all together. There we go. So when we multiply them all together, we're going to say 10x squared y4 times 4.3 xy negative 2 and 3.5 x cubed y squared. So guys, when we're multiplying all these guys together, what's the first thing that we're going to do? What do we do to our coefficients, guys, when we multiply? The coefficients? We multiply our coefficients. So guys, our coefficients, we do 10 times 4.3 times 3.5, right? So that's what? 43 times 3.5. Ooh, gosh, so yeah, I'm going to grab my calculator. So 10 times 4.3 times 3.5. Yep, there we go, 150.5. Now, Raihana, what do we do to our exponents? Add them. So we have x squared, x1, and x3. So that gives me x to the 6th. And then this one's interesting because we have a negative exponent, but we can still add them. y4, y negative 2, and y positive 2. So that gives me y4. 4 minus 2 plus 2 is y4. Do y'all feel okay with this? This is just putting it into application. So you have to decide, because we're doing our product rule right here, we are going to add our exponents together. All right? You would do the exact same thing on number 5, right? But this time we're not finding the volume, we're only finding the area. So we're going to multiply the two together. You guys feel good about that? So how would we set this one up? You want to help me out? Let's see here. Miss Luz, how did we set up number 5? You're good. You can phone a friend if you want. All right, Joy, help us out. How do we set it up? Okay, so guys, here we go. If the area of a parallelogram is your base times your height, guys, do we know the base? Yeah. Okay. Do we know the height? Yeah. So what are we going to do? Yes, go for it, Bella. Yep. 5r squared t times 6r t to the 5th. All we're doing is we're multiplying them together. You're absolutely correct. So guys, when we multiply them together, we're doing our product rule. So we do 5 times 6, which gives us 30. And then we are going to do r squared times r1. So that gives me r3. And then we do t1 and t5. So that gives me t6. So guys, my area is equal to 30 r cubed t6. Cool? Or t to the 6. All right, last one here. I like this one. Guys, it says the volume of a cube is this right here at 144 x4 y5 cubic inches, units. And the area of its base is 18 x cubed y cubed. What is the length, or L, of an edge of the cube? So guys, now we have to divide. That's exactly correct. In order to find that length, guys, we are going to need to do the volume divided by that area. So it becomes that 144 x4 y to the 5th over 18 x cubed y cubed. So guys, in this case, we are going to divide. So guys, let's look at this one right here. I like to go ahead and draw my little fraction bar so that I have it out to the side. 144 over 18. What is that going to, that is going to be 8. Now, I guess I can put 8 over 1. I don't know if I really need it. But guys, it's going to be that 8. 144 divided by 18. Yes. Why is it x1?
Because x4 minus x3.
Yes, x4 over x3. We subtract those exponents, so that's x1. And then y5 over y3, that is y2. Guys, why did both of my variables end up on top?
Because
Go
they're
ahead.
higher.
Go ahead. Go for it. Yeah, Julia.
Because like the bottom number is like smaller than the top number.
The bottom number is smaller than the top number. The exponent in the numerator is larger than the exponent in the denominator, so it kind of like has more gravity and it pulls it up. Okay? So obviously we don't need now to write it with that 1 on the bottom. So guys, we would write 8xy squared. That would be our final answer. Okay? Because you don't really need to write x to the 1. Are you guys comfortable with these kind of problems right here? Yes, sir?
Will we get a point off if we just put x1?
No, you would not get any points off if you put x to the 1. But if it was a multiple choice problem, you would never see it with the 1 as an exponent. Okay? So, are you guys comfortable with these guys? Awesome. So what I want you guys to do is I want you guys to flip your paper over. And guys, we are going to look at some mixed practice problems, okay? So we're going to look at some of these. All right? Number 1, I'm going to do these first 3 right here because, guys, I want us to get in the habit of doing some of these together. I'm not going to do every single one of these with you guys, but I just want to do a few of them. Okay? So we have 10xy squared to the 3rd power x squared. So, guys, this is where we get in trouble, is when we got a lot of things going on. So, guys, first we got to do that power to power rule. But, y'all, what is that 3 raising? Is it the 10?
Why?
It's just the x and the y. So, guys, that becomes x cubed, y6. Are y'all comfortable with that? So I'm going to do my power to power rule first. And then I'm going to, now that I've taken care of my power to power rule, I can do my product rule. Does that make sense, guys? You kind of have to do one at a time until it simplifies out. All right? So, guys, we have this one right here. So, we have 10x cubed. All right, so this is the only coefficient. So, I'm just going to bring that 10 down. Then, guys, we have x cubed and x squared. So, that's x to the 5th. And then, guys, we have y to the 6th. So, that actually wasn't so bad. 10x to the 5th, y to the 6th. Y'all cool with that? Now, for this particular one, this one's interesting, all right, because we have 0 exponents, we have negative exponents, so there's a few ways that we can do this. So first of all, guys, when you have a 0 exponent, do y'all remember what the rule is? Yeah? It's equal to 1. So, guys, 15, if it's times 1, do I really need to even include that in my answer? No. So, guys, if I see a to the 0, I'm going to cross that little guy off because it's times 1. If I see c to the 0, I'm going to cross that little guy off because it's times 1. So now, I'm just going to do my product rule. So 15 times 3, so that gives me 45. And then we had one a that we crossed off. But now we have our other little a right here. So that's a to the 16 because there's nothing else adding to it. And then we have b squared and b negative 29. Good Lord. So what's 2 minus 29, y'all? Ugh. Negative 27. And then last but certainly not least, we have C34. Oh, and then the other C was crossed off. So it was just C34. So guys, remember, can we have negative exponents in our answer? No. So guys, when you have a negative exponent, where does it need to go? It's got to go downstairs, so it's going to go on the bottom. So guys, if we rewrite this, we would write 45, A16, C34. Those guys were left on top. But then my little b would have to go downstairs to B27. Okay? Now, guys, here's one analogy that I used for my negative exponents, and I forgot to do this in class the other day. But, guys, when you were a little kid, and maybe even now, this is what I do with my sweet children, is when they have a bad attitude, sometimes you just need to, just go upstairs, take a minute, take a deep breath, change your location, and then you'll be a little bit happier, right? So it's kind of the same thing with your negative exponents. If they're grumpy, just send them downstairs, and then they'll become happier, okay? So, let them change their location, and then their attitude will adjust, and they'll become happier. So if you have negative exponents that are grumpy, just send them downstairs, and then they'll be happy, all right? If you have negative exponents downstairs that are grumpy, send them upstairs, and they'll become happier, okay? Now, guys, this one's interesting. When you have a negative exponent to an entire thing right here, guys, now everything in here is grumpy, okay? So what we are going to do is, guys, we can rewrite this is if you flip the entire fraction. So we're going to flip the y squared to the top and the 3x to the bottom. And then we raise it to the third power. So we're going to flip both of them because they all got a negative exponent. We flip them both. They change locations, and then they become a whole lot happier.
Why did you flip them?
Because that negative exponent on the outside. So, Emery, I could have multiplied that negative exponent in, but then if I multiplied that negative exponent in, we would have ended up having to flip them all because then they would have had negative exponents. Does that make sense? So you might as well just flip it at the start, and it's a little bit easier. And then we're just multiplying it in. So then we say y squared to the third power. So the top of my fraction is now y to the 6th. And then, guys, the bottom down here, we would say 3. It's not 3 times 3. It's 3 to the third power. And then we say x to the third power. Okay, guys? So now, what is 3 to the third power? Yep. So what's 3 times 3 times 3, y'all? There we go. So that's y to the 6th over 27x cubed. So guys, remember our power to power rule. When you have a coefficient, you raise it to the third power. You raise it to that power. Okay? Yes, what's up?
I'm kind of confused on how exactly that happened.
Which one? Which step? Going from here to here, the flipping?
No, the 3x. Oh, wait, the x. Oh.
The x has like a 1 exponent, so what's 1 times 3? That's 3.
I thought the x was an exponent.
Okay. Does that make sense? Oh, no, the x is not an exponent. All right, guys? Do you have any questions for me on these guys right here? So, guys, here's the deal with negative exponents. Let's look at number 6. Negative exponents are weird. All right, guys? Because you can either, for number 6, this one's interesting. You have a power to power. So, guys, check this out. You can simplify number 6 before you do the power to power, or you can simplify it after. Okay? So, guys, what do we want to do? What would y'all prefer to do? Would y'all rather bring that 2 in and do the power to power rule first, or would you rather simplify the fraction first and then do the power to power? All right, let's simplify first. So what we're going to do is everything is still going to be raised up to the second power. We're not going to mess with that one right here. But we're going to simplify our fraction first. So that becomes 3 over 2. Excellent. And then, guys, now we are going to look at our m's. M2 over M3. So, guys, when we are dividing, we subtract. Okay, guys? So, where's my larger exponent?
Down.
On the bottom. So that's going to end up with M1 on the bottom. Y'all cool with that? 3 minus 2. And then what we are going to do, y'all, is we see, okay, t to the 5 over t to the negative 1. But guys, that negative exponent's got a grumpy attitude, so it's going to need to come upstairs. So now what are we going to do to those lovely little exponents? We add them together. So that's going to become t to the 6th on top. So guys, now we've simplified our fraction first. Now we can do the power to power rule. Okay? So if we do our lovely little power to power rule, remember, we are going to raise that. That is going to be 3 to the 2nd power. And then it's going to be t to the 12th over 2 to the 2nd power over m to the 2nd. All right? And we're almost there. Now we just got to simplify our coefficients there. So, y'all, what is 3 squared? 9. It is not 6. It is not 3 times 2. It's 3 times 3. So that's 9t12 over 4m squared. Are you guys comfortable with that? So that would be if we simplified our exponent. We simplified the fraction first. Okay, guys? I do want to show you something kind of cool. If you hadn't have simplified your fraction first, I did it a different way on the key. Guys, if you multiplied all of your power to powers in first, then you would have had 9m4t10 over 4m6 t negative 2. And guys, we still would have ended up with 9t12 over 4m squared. So either way you cut it, you're still going to get the final answer. So you can simplify your fractions before you do the power to power or after you do the power to power. Okay? You guys feel comfortable with that? So guys, there's a lot of lovely little mixed practice problems on this page. So I would like you guys, we have, so guys, this right here, I want you guys to have this. This is a really good resource for you to practice, especially before you get to the test next week. So guys, the key for this is on my Canvas page, so you guys can use this for extra practice. But right now, I want to give you all these last 20 minutes of class to actually work on some of your homework. So go ahead, grab a Chromebook, and you guys can get started on your homework.